Thin layer chromatography. What is it? Basically, it is an analytical technique that is utilized to separate non-volatile mixtures. It is a type of liquid chromatography. Now, this is an extremely essential tool in the field of forensics. Routinely and commonly used for sampling, but not subject to, drugs, explosives, inks, along with biological samples, such as saliva, urine, and even blood. Now, something you need to know is thin layer chromatography has two very crucial phases. Firstly, there's the stationary phase, and secondly, there's the mobile phase. Remember that, because it's important. So what about the actual procedure? Firstly, it is important that it is performed on a glass, plastic, or aluminium plate, which is to be coated with a thin layer of silica gel. And this, as a result, is what is known as the stationary phase. A straight line is then drawn near the bottom of the plate, and the sample in question is then dotted somewhere on that line. It is then placed within a beaker, with it hung above and slightly immersed in a solution or a mixture. And then this is to be what is known as the mobile phase. So what's the point in all this? This process allows for the solvent to be gradually drawn up the plate through what is known as capillary action, separating the individual components of the sample, as can be seen right here, represented by the multiple colors. Now always remember this, the component which is more soluble within the sample will travel a further distance up the plate via capillary action, and that which is less soluble will travel a shorter distance. Great, so the process is relatively simple. What's next? First, you need to check whether the separated components are colorless or not. Now, if this is the case, you're able to spray the plate with a visualizing agent, or even viewing the plate under a UV light. Either works. Now, here's the not so fun stuff. After this process complete comes the math. Sort of. Now remember, TLC results are represented as what is known as retention factor values, or RF. This is the distance traveled by the substance divided by the distance traveled by the solvent. Two very different measurements, so know the difference. Now this next part kind of goes without saying. A negative control, positive control, and a reference standard respectively are also to be spotted along the same line. This is to allow for a comparison of their RF values. Now this analytical technique has definitely proven its value in forensic science as being efficient, selective, and flexible due to the great variety of layers for the stationary phase, which, as I previously mentioned, is whatever the plate is coated with prior to dotting of the sample, as well as proving itself to be just as sensitive as the popular analytical technique HPLC. Now, although TLC cannot conclusively identify a sample, it can be used as an indicator of the components before more advanced analytical techniques such as gas chromatography or high-performance liquid chromatography is used.